So we're looking at section 2.5. We've been studying linear equations. We're going to look at some applications of those. So our objectives today to write linear equations that model real-world data and make predictions from those models. Okay. A scatter plot. Have you heard that term before? Scatter plot? All right. That's where we just plot a whole bunch of data points. And we're trying to determine what kind of shape we're seeing. Okay? So a scatter plot just shows us the relationship between two sets of data. We're graphing them as if they were ordered pairs. The correlation describes how closely that data fits. All right? So if you look at the pictures we have here, we have everything from a strong negative to a strong positive correlation. Strong negative means that our points are lining up very close to a line. Okay, they're very close to that line and they're going in a negative sloping direction. Does that make sense? As the points spread out, it gets harder and harder to figure out where that line should go. Okay, so we call that a weak negative correlation. It's still, they're sloping down, so it's still a negative slope idea, but they're not as close together, okay? The line isn't quite as obvious. In the middle here, we have no correlation. Our dots are all over the place. We can't tell, are those supposed to be going in a positive direction, a negative direction? There's really no way I could come up with a line for that, okay? Going the other direction, we have weak positive and strong positive. Again, strong means they're very close. We can pretty much see a line going through that, even though not all the points are on the line. Does that make sense? Okay. So if I asked you to analyze this data, it says it lists the average monthly temperatures and electricity costs for a Texas home in 2008. The table displays the values rounded to the nearest whole number. So we have 12 sets of data from January through December. We are given a temperature and what the electric bill was. Okay? If we were to graph all of that, we'd be able to see what type of correlation we have. Okay? And just to save some time, I've already graphed it for you, so I'm not going to have you graph this one. But let's look at what the picture looks like. Okay? There is a scatter plot of this data. So, would you describe this as a positive or negative correlation? Positive, because it looks like our points are going up, right? Okay, so in this context, as the temperature rises, right? Temperature was our x-coordinate. As the temperature gets hotter, they probably run the air conditioner more, right? This is a Texas home, so their electric bill is going to go up. Does that make sense? Okay. Is it a strong or weak positive? It's pretty strong. Those points really look pretty close to a line, right? They're not all going to be on the line, but they look pretty close. So for our analysis here, go ahead and just do a quick sketch, all right, to show what that graph looked like. I know we haven't plotted the points. Again, we're doing this for time's sake. But we would describe this as a strong positive. Okay. The next question says, what would you expect to pay for the electricity if the average temperature was 70 degrees? So if we went back to our graph here, and I will tell you that the tick marks on the x-axis are going by tens, so we could count over to 70, correct? So 10, 20, 30, 40, 50, 60, this is 70 here. Could we look up and kind of predict, okay, if there was a line going through that, what is my y value going to be? We could make that prediction from our graph, yes? Now, if we had an actual line drawn through there, it would be even easier to make that prediction. Okay, so that's what we're going to be doing today. We're going to be trying to come up with these lines. All right, it can be very time-consuming to do this by hand. We're going to talk through what would be involved in doing it by hand. but then we're going to move right to the calculators, okay? So I'm not going to test you on doing these by hand. We're going to use the calculators. All right. So looking at our set of data here, it says the table shows the number of hours students spent online the day before a test and their test scores. Make a scatter plot and describe the correlation. We should be able, from our t-chart, to determine if this is a positive or negative situation, right? If your x values, which in this case is the time they spent online versus studying for their test, right? So what happens as you spend more time online and you don't study for your test? Scores are going to go down. So as the number of hours spent online increases here, right? Look at your test scores. They're going from 100 down into the F range. Yes? Okay. So if we were to look at this as our time, hours online, increases as we go this direction, what happens to our test score? It's going down. So we should expect to see points that are going down. Yes? Okay. We're going to come back to this data and use the calculator for it. All right. But if your data is in order, I want to emphasize this. Our X values were going up, correct? So if they're organized in that direction, then we can say, is my Y values getting higher or lower? But sometimes you'll have data that's kind of all over the place, right? And you would really need to see the graph before you could make that prediction. Okay, we'll come back to this data in a little bit. So there's something called a trend line. The line approximates the relationship between two variables or sets of data for a scatter plot. The line can be used to make predictions from our data. So if we were doing this by hand, okay, these are the steps we would take. Our first step would be to plot all of our points. Okay, we're going to make a scatter plot. We're going to look at what makes sense. In this example, it's asking us to come up with an equation for a trend line that models a relationship between time and home price. Use the equation to make predictions about the median home price in 2020. So we have values here since 1940 on up to 2000. Okay? When you make a scatter plot, it's important to determine, well, what should be my X coordinate, what should be my Y coordinate? Okay? So we've set it up. In this case, X is our time, all right? And Y would be the median income. Okay? Or sorry, the median home price. Now, one thing I do want to point out to you, this is really common. If you look at your table of values, our first year was what? In that table of values, what was the first year that we had data for? 1940, and then it went to 1950, 1960, right? It is really common, instead of having our x-axis have to start with 1940, we want to adjust it. So what they've stated here is that the numbers in our x direction here represent the years since 1940. Okay, so they're adjusting it. That means time 0 here is 1940. Time 10 would be 1950. Does that make sense? And you do have to pay attention to that when you're setting up and using the calculator to come up with your line. Okay? It's much easier to type in 0, 10, 20, 30, 40 as opposed to those big year numbers. Okay? So that's really common. Watch for that. All right. So if we were graphing this by hand, we would have to determine which is our independent variable, or are the x's. Which one would be the dependent or the y values? Okay? Which axis should each variable be on? What kind of scale do we need to use? We'd base this all on on the data we have. Okay? How big is this data? How do I need to adjust the scale? In this case, they went by 10-year increments, and they went by 20,000 plus for the y-axis. Yes? Okay. They actually went by 10,000s for the y-axis, but they've only labeled every other one. Does that make sense? And we can do that on our graphing calculator as well. Okay. Step 2, once you've made the scatter plot, they've plotted the data, you would sketch what we call a trend line. So you would take a ruler and you'd look at your data and say, what seems to be the best line I can draw? Okay. Again, the more strength there is in the correlation, the easier this is. If your data is really spread out, it's hard to figure out where that line should be. Your goal would be to try to balance it a little bit. If you have points above the line, you'd want to balance them with points below the line. Does that make sense? So typically we have a few points above and we have it balanced with a few points below. Okay? We would then choose 2 points on the line. I want to emphasize that. If our line doesn't actually go through any points that you plotted, which can happen, I could have data like this, right? And my line's going to go right through the middle of it. I have to pick 2 points on the line that I've drawn, even though they're not data points from my table. Okay? From those 2 points, we can find the slope. We can plug it into that slope-intercept form. We could come up with our equation. Yes? But again, all of that is time consuming. To graph it by hand, to try to figure out where that best line should be, and then to actually do the calculation. Your calculator can do all of that. Okay? And much more precisely. All right. Once we have that equation, we can use it to make predictions. Okay? So, we are going to go through the calculator steps. There's a couple things that I want you to check first. So everybody grab your calculators out and we'll get started in just a sec. All right. So first thing we want to do is we want to clear out any data. Okay? Or any equation, sorry. I'm going to quit that. Then I need to make sure that the diagnostics are turned on. If you ever have to clear your calculator for some kind of standardized test, okay, it will default back to the diagnostics being off. So you typically have to go back in and turn it back on again. Okay, so let's just check how we do that. Do second the 0 key, and then you're going to scroll down. You're looking for the word diagnostics on. Okay. And you want to hit enter where you're at diagnostics on. Then you have to hit enter again. It has to say done. It's turned them on. Okay? All right. Now, as long as you don't completely reset your calculator, it should stay on for what we need. Okay? The other thing that we're going to be doing is we're going to be turning on a stat plot. Okay? So we'll go through that setup in just a sec. Let's go ahead and catch up here on our notes. So when you figure out the line by hand, it's called a trend line. When you use your calculator to find it, we refer to it as the line of best fit. Okay? Your calculator is going to come up with the best possible line. When you do it by hand, you may not have the best line. Okay? We can use what's called a linear regression. All right, we're going to let our calculator do that. It's going to find that line of best fit for us. The correlation coefficient, they use the letter R to represent that. It indicates the strength of the correlation. the closer your R value is to a -1 or a +1, the stronger the correlation. If you're actually at an R value of 1, it means it's a perfect fit. And it's going in a positive direction. Okay? If you're at a -1, it means it's a perfect fit, but it's in a negative direction. All right? So, +1 means strong positive. A -1 would be a strong negative. Okay? And you can be anywhere in between there. So your correlation coefficient might come up as 0.95. Means it's really strong, but it's not perfect. All right? There's something in your data that's not quite fitting that line. If you get a correlation coefficient of 0.5, it's weak. All right? I wouldn't base a lot of predictions on that line because it's not a great line. It's not a great fit. Okay? All right, so we're going to start with this data. It says you researched the cost of movie tickets for recent years to look for trends. The table shows your data. We want to come up with an equation for our line of best fit. We also want to determine how accurate that is. Okay? Based on that linear model that our calculator gives us, we're going to make a prediction of what we would expect to pay for a movie ticket in the year 2025. Okay? So we have some steps listed here. The first one is to use our stat feature to enter the data. In other words, we have to enter this T-chart into our calculator. Okay? We are going to go to our stat key and then to edit. Your stat key is right here. Okay, in red here. So press the stat key. Notice it gives me 3 options now. I can edit, I can calculate, or I can run tests. We're not going to use the test feature at all here. We're going to use the editing and the calculating. You need to edit the table. Okay, you need to enter that data. So hit enter here. We're going to enter our data into our calculator. Now, I have data in there from that first example that I showed you a picture of. Okay, I want to have you watch how I clear that data out because it's important that you do it in the right steps here. So what I want to do is I want to clear the list. I do not want to delete it. Deleting it means the whole column disappears and I no longer have a list 1. Do you see at the top where it says L1, L2, L3? Okay. I don't want to take list 1 away. I just want to clear it out. Does that make sense? So we arrow up to where it says L1. We hit the clear key, which is over here under your arrow keys. And then we arrow back down and it will clear out that data. Do not try to type over the data because if your new list has less data values than the old list did, you're going to have some at the bottom that you can't get rid of. Okay? So you always want to clear it before you enter a new set. All right, so I'm going to do the same thing. I'm going to arrow over and up to list 2, hit clear, and then arrow back down. Okay? All right, let's go back to list 1. We set this up to let 1995 be year 0. Okay? So in my table, 1995, for my list 1, I'm actually going to put a 0 in. Okay, this is what I meant earlier when I said we're going to adjust it so our numbers aren't quite so big for X. 1997 would then be what? 2. And then 1999, 4. 2001 would be 6 years later, 2003, 8, 10, and 12. Yes? So we aren't going to enter this. We're going to enter the 0 to 4. Okay? That will be our list 1. This will be our list 2. Okay? So we are going to enter that data onto our calculator here. All right. So I've put in 0 through 12 going by 2s in my list 1. Bless you. Arrow over to list 2. Now we need to actually put in the ticket price. All right, so 4.35 is our first one. So you type the number, hit enter, and it'll move you down. 4.59, 5.06, 5.65, 6.03, 6.41, and 6.88. Now, before you move on, look at your numbers. It's very easy to type a wrong number. It's going to give you the wrong answer, okay? The other thing is to make sure that your X's and Y's match up. In other words, the first row in that list should be my ordered pair, right? The X goes with the Y. If you get an error message when you try to do these next steps that says dim mismatch, dimension mismatch, it means your table didn't line up. You had more X's than Y's, right? And it was trying to pair up the data and it couldn't. So a dimension mismatch, go back to your table and check over your values. Maybe you forgot to hit enter on the last one. Okay? All right, so we've done step 1. We've entered our data. Step 2 is to actually look at the picture of it, right? We want to see the graph of it. To do that, we need to tell our calculator to set up a stat plot, and we need to make sure that we set up a window that allows us to see our data. If our window on our calculator is set to -10 to 10, that standard graphing window, we won't see values that are 12s. Does that make sense? So we need to adjust that window based on our data. Okay. So let's get our stat plot turned on. You can quit out of this screen, just do second and then the key right next to it. That's your quit. And let's go in and set up our stat plot. So stat plot is right above the y equals key. So you're going to hit second y equals. Okay? Second y equals. So how do they quit out of here? Oh. Okay, so right now I have one turned on because I showed you that picture at the beginning of notes. Okay, yours are probably turned off. And one thing to keep in mind when we finish this unit and you go to try and graph other stuff later chapters, if you get some error messages, it's probably because you left this on. All right, so when we finish all this stuff, you'll want to turn the stat plots back off. Okay. So plot 1, I need it to be on. So have 1 highlighted, hit enter, and it's going to take you into that stat plot. Highlight the word on, hit enter again. Then you're going to choose the type. Now, there's different types of graph. There's bar graphs, there's box and whisker plots. We just want that first picture, the little scatter plot. Okay? Then we have to tell it where to find our data. We stored our X's in list 1 and our Y's in list 2. Okay? But do you remember in that list screen there were like 6 different lists? Sometimes you want to compare 2 different sets of data. So you might have list 1 and 2 be one set of data and list 3 and 4 be another. You can change which lists your calculator looks at. Okay? Look at your number keys down here, the 1, 2, 3, 4, 5, 6. Do you see right above it? It says L1, L2. So you can change them using those. Okay? So for example, if I didn't want list 1 there, I could do second 3 and change it to list 3. Okay? We'll put it back to list 1. All right, now for the mark, I typically will use the little box, the little square, or the plus sign. A dot gets very hard to see if you have a lot of data in a big window. Okay, so I would use one of the bigger symbols. Okay, so I have mine set to be a little square. And then this calculator does them in color. If yours doesn't, that's fine. It doesn't need to be in color. Okay. The next thing that we want to do, we've put our scatter plot in, we've turned it on, we've told the calculator which lists to use, we've put down what kind of mark we want. We now have to set the window. So go to your window key. Your window is right next to your y equals screen, or your y equals key. And we're going to adjust the window to fit this data. All right, so if I look at my data, my x's went from 0 to 12. I typically will go a little bit on either end of that to make it a little bigger so that my end point isn't right on the corner of that screen on your calculator, okay? So I'd probably say let's go from maybe -5 to 15. Give us a little cushion, okay? So for my x's, I'm going to set it to go from -5 to 15, okay? Your x scale is how often you want to see a tick mark. For a small window like this, we could go by ones. But on that example I showed you at the beginning of class, I went by tens because my window was so big. Does that make sense? You can even turn it to 0 if you want. You don't need to have the tick marks in there. All right, for our y values, let's look at our data again. We had a 4.35 up to a 6.88. So if we went from 0 to 10, would we see all of that? Okay, let's go ahead and do that. So my y min will be 0, and my y max will be 10. All right, and I'll just go by ones again for that. Okay, so we've set the window. Now we can look at our graph. So hit the graph key. There's our data. Does it look fairly linear? Can you picture drawing a line through it? Okay. So we would describe this as what kind of correlation? Strong, positive. Yep. All right. Step 3, we want the calculator to come up with our equation. Okay. To do that, we're going to go back to our stat key, but this time we're going to move over to calculate. All right. So stat key, arrow over to calculate. And there's all different kinds of regressions our calculator can do. So if we had data that looked like a parabola, we could have it do a quadratic regression. Okay? But we're trying to do a linear regression, right? We said our data looked like it was a line. So we're going to go to number 4 where it says linear regression. You can arrow down or you can just type the number 4. Okay? Now, different calculators have different screens at this point. Okay, so I'm going to talk through this one and then I'll pause the video and troubleshoot any that look a little different. Okay? This says I'm going to pull my x's from list 1 and my y's from list 2. Is that correct? Yes, so we can skip that. We are going to store our equation, and I'll show you why in a minute. For our storing, we are going to do the variable key. It says vars. Then we're going to arrow over to y vars. Then we're going to choose number 1, and then we're going to choose number 1 again. Okay? I'll pause in a second and give you time to write that down. What it looks like over here. Our variable key is right here next to our clear key. So I hit variables. I arrow over to y variables. I choose the first option. I want a function. And I'm going to store it in y1. Okay? It's going to go in my first equation spot. So now I have this. My calculator is going to store that once it comes up with the equation in y1. Why that's nice is because a lot of times these equations have a lot of decimal numbers. You don't want to have to type it by hand. So it'll dump it in for us. Okay? We can go down to calculate, hit enter, and there's my equation. Okay? Now, what do these pieces mean? Notice at the top it says the format they're using is y equals ax plus b. They're telling me a is 0.21785 and b is 4.26. So we could round that and we could say y equals 0.218 times x plus 4.26. Look at our R value, 0.996. That's a really strong positive correlation, right? The closer we are to 1, the better the fit. Okay. All right, I'm going to pause the video for just a second and we'll check in with everybody. All right, so once you get to this screen, we are given our A and B values. We can write our equation. All right, so my equation for this would be y equals we'll just round to 0.218 x plus 4.26. Okay. Now, if you hit graph, it's going to draw the equation in. So before we had just the dots, now we can see the line that it came up with. Does that make sense? If you're not getting that line, it means you didn't store it. Okay? So when I go to y equals, it dumped in that big long decimal equation for me. Does that make sense? Okay. The last part that I wanted to show you, the reason we've been storing this equation is because we can then let our calculator use it to help us make predictions. So if we go back to this example, we have our equation was y equals, what was it, 0.218 x plus 4.26? Okay. Now it says, based on that model, how much would we expect to pay for a movie ticket in 2025? We have to adjust this because remember we said times 0 was 1995? So if x equaling 0 means 1995, what would my x value be for 2025? That's 30 years later, yes? So I'm going to put a 30 in for x. I can do this by hand. I can physically dump a 30 in there and calculate 0.218 times 30 plus 4.26. I can do that, right? Or I can go to my calculator. I can go to my table. So second graph is table. And I can find where x is 30. Now I've adjusted mine for some other data that I had. You can change how your table starts. So I did second window to this table set, and I can just say, hey, I want to start at 30. Start my table with x being 30, then when I look at my table, I have it. The price in 2025 for a movie ticket was $10.80. Okay? Yes. All right, so with the little bit of time that we have left, I would like you guys to practice on this. I'm going to go ahead and put the homework up here. All right, you guys are just going to do 7 through 17 odd. So I'm not giving you a lot of them because I know it takes a while to get through each one. Make sure that you are giving me a sketch of your scatter plot. You don't have to draw it by hand. Okay? We are going to do all of it with the graphing calculator. Okay? You're going to do all of it with a graphing calculator, even if it calls it a trend line. Okay.